In this video, similarly to the limit as x goes to 0 of 1 minus cosine x divided by x, we're going to be proving the limit as x goes to 0 of cosine x minus 1 divided by x is equal to 0. Likewise, to the limit as x goes to 0 of 1 minus cosine x divided by x. So to prove this limit, we, likewise for how we did it for this limit in the previous video, we multiply by the cosine x minus 1's conjugate. So this becomes the limit times cosine x plus 1 divided by cosine x plus 1. This can be then equal to, if we combine cosine x plus 1 into the numerator and denominator, cosine squared x minus 1 divided by x times cosine x plus 1. I can do this because of a formula which states that a squared minus b squared is equal to parentheses a plus b times a minus b, and our a term in this specific case of cosine x and our b term being equal to 1. Therefore, I can obtain the final result of cosine squared x minus 1 in the numerator. And with that in the numerator, I can further rewrite this to be equal to the limit as x goes to 0 of, if we factor out the negative symbol, negative parentheses 1 minus cosine squared x divided by x times cosine x plus 1, which can then be equal to the limit as x goes to 0 of negative sine squared x over x times cosine x plus 1. And the reason why I can do this is because of the Pythagorean theorem, the Pythagorean identity rather, for trigonometry, which states that the sine squared theta plus the cosine squared theta is equal to 1. Therefore, sine squared theta being equal to 1 minus cosine squared theta. This form for sine squared theta is present within our numerator for this term right here, hence deriving this limit as such. And with that, we can rewrite the numerator to be right here equal to the limit as x goes to 0 of negative sine x times sine x divided by x times parentheses the cosine x plus 1. This can then be equal to the product of two limits, which are the limit as x goes to 0 of sine x over x times the limit as x goes to 0 of negative sine x over cosine x plus 1. The reason why I can do this is because of a trig identity, or rather limit identity, which states that the limit as our input of x approaches any number of n of the product of two functions represented by f of x and g of x is equal to the limit as x approaches to a number of n of our first function f of x times our second function, limit as x goes to n of g of x. Therefore, we have broken up the limit as such. And we know from another limit identity, which states that the limit as x goes to 0 of sine x over x is equal to 1. With this limit, which we're going to be proving in future videos, but for now accepted as true, this limit right here will become nothing more but 1. So the product of these two limits becomes 1 times this limit right here. And to evaluate this limit, we can simply substitute x is equal to 0 into the limit, which is one way to solve limits, which can then be rewritten as negative sine of 0 degrees, or rather negative sine of 0 radians divided by the cosine of 0 radians plus 1. And we know that the sine of 0 from our special angles for trigonometry, that 1 times negative sine of 0 will be 0, negative 0 being 0, cosine 0 being 1, 1 plus 1 being equal to 2. 1 times 0 over 2 will give us 0, because 0 divided by any number will be equal to 0. Therefore, we have proved the limit as the x goes to 0 of cosine of x minus 1 divided by x is equal to 0, along with the limit as x goes to 0 of 1 minus cosine x divided by x, which I proved in the previous video.